Okay, why does dy dx greater than 0 for all x means that the curve has at most one root? Well, the answer is very straightforward, actually. I know that this string of rubbish here may not seem to make sense, so let's break it down. What is dy dx? Dy dx is the gradient of the curve. When I say dy dx is greater than 0 for all x, what am I saying? It just means it's, right, a very happy guy, positive. Okay, it implies at most one root. And what does that mean? Well, we know that for a quadratic, the intersections with the x-axis is the roots. So we know that quadratic typically has two roots. So we know that a root means axis. Okay, and we also know that the x-axis is the line y equals to 0. Okay, so we're going to put this all together, and this is the explanation here. Okay, we start off with this. This is given. So you tell me that dy dx is greater than 0. Okay, I know that the curve probably looks something like this. I don't know, but it's always increasing. Okay, recall that gradient is the line here. So long as the line is always going upwards, positive. The moment the line is parallel to the x-axis, then your dy dx equals to 0. This is not what we want here, and as you can see from my graph, we did not have that. How do I know? Well, it did not have a turning point. We know that dy dx is turning point, correct? There is no turning point on my graph here. Okay, and what about dy dx smaller than 0? Well, then it has to be a downward pointing, and as it is not what we want again, as we can see, there is no downward pointing arrow on my graph. Okay, so this is what we mean by dy dx is greater than 0. Now, is this the only function? No, there are many other functions. This is always increasing. This is always increasing. Okay, with the exception of this. That's not good. Draw it one more time. Maybe something like this. Always increasing. Okay, so over here I just have a... Oh, is this ever increasing? Yes, still increasing. Okay, so all of it, all the tangents when I draw is pointing upwards, so that's always increasing. Okay, so I make this deduction. And based on what we have drawn up here, I conclude this. Always increasing its y value. Can you see that? Every single point, I take this point here, as my x moves along the axis, is going up. Here, going up here. It keeps going up. Imagine if you're on an elevator that keeps going up. So the elevator is going up. And at the same time, I'm moving the elevator along this graph here, okay? From left to right. Will you ever visit the same level? Let's say you're at B1 here, and you're going up to the first floor, but the elevator shifts this much, okay? Then you go to the first floor, and the elevator shifts this much, you go to second floor. The elevator shifts this much, you go to the third floor. Okay, but what I tell you is, the elevator keeps going up. Will you ever get back to the first floor? No. Will you ever get back to B1? No. Okay, so that's the idea here. So see this explanation. Okay, actually for whatever particular level, the curve will never revisit that point. So in this case, since we're only interested in the x-axis, we're looking at this level here. Will the curve ever come back here? Will you, sir, come back to the axis and intersect it? The answer is no if you're always increasing. Okay, get the idea? Therefore, I conclude this. So at most there's one root means there's one intersection. Okay, another way to explain this is using turning point. You can say that this. Okay, if you use this explanation, it's also accepted because it has the same meaning. No turning point plus the fact that it's in one direction, it means that you have eliminated the other two options, and with our deductions here, it would be the same thing. So if you give this explanation, it is also accepted. Okay, but I'm giving you the lengthy one so that you can understand the proof under the hood. So let's recap. In fact, is this always unique to always positive? No, always negative can be thought the same way. It's just always going down, but it will never revisit the same level. Okay, and what about if dy dx equals to 0 for all values? Well, then we just say that it's a straight line, you know. Correct? So it depends whether the line is the x-axis itself. But that's a trivial case, they're unlikely to ask it. Okay, so if dy dx is greater than 0 or smaller than 0 for all x, we know that is at most one root. Explanation I have explained. Okay, all the best.